Hi, in this tutorial we will explore more of the advanced meshing features of GSA Grasshopper using the create elements from members functionality. So this component lives under geometry and down here elements from members. Um, both the create model component and the analyze component also got this functionality built into them. So you can automatically trigger this by ticking these elements from members boxes on those two components. The elements from members components is just doing it automatically and importing the elements back in again. And that enables us to view what we're doing straight inside Rhino and Grasshopper. And therefore we can see the mesh that we're creating. So meshing is all about 2D members, so we need to create the members first, and from there on we can create the elements or the meshes. So I'm going to use the create member 2D component, also found here under the geometry tab. I'm going to first create a rectangle for the boundary, and then let's try and mesh that. So use the built-in Grasshopper component called rectangle to create a rectangle, and give it some arbitrary numbers here that we can see already is a boundary representation. We can input that into the B input, and then we can input that into the member 2D here, and then we can see that that has already created a mesh. So the way that GSA previews meshes is a little bit faint, so in order for this video to show a little bit better, I'm going to use the mesh edges component to show the edges a little bit better. So there we go, now they're red. So the element 2D can be converted straight into a mesh, and therefore we can take the edges directly like this. So let's make it a little bit more advanced. Let's introduce a hole in this surface. So let's make a circular hole. I'm going to make a circle component here. We can see that automatically places it at the global 0. So maybe we want to place that in the center of our surface. We can use the area component to get the center point. And like that. Just gonna give myself a little bit more space here. And so now that is in the middle, and then we can give it a proper radius. So maybe something like this. We can combine the original rectangle with the circle into a boundary surfaces component that will automatically create this void like this. You can't see that because it's hidden, so there we go. And if we input that like that, and now I'm going to hide this instead. So you can see that has created a nice perpendicular to the opening, to the edge mesh, and yeah, looks pretty good. We can change everything here parametrically, of course, and we can also start changing the mesh size. So it's the bottom input here, and you can see how it creates a mainly quad mesh with a few triangles to transition between the two directions. And yeah, you can see how it's really fast. You can change all the dimensions here. We can also include points. So if I, for instance, let's scale this rectangle inwards, scale it around the center point. Maybe we say 0.05, maybe like this. Then if we explode this, we can get the corner points of that. If we then include these points, I'm gonna hide here. If we include these points in the member 2D, we can see that these points have now been included in the mesh as well. So that's pretty nice. We can also include the curves, of course, if we want to. So this will then create a mesh that has these lines included, and they're noding out. But the downside by doing it this way is that we can't control the mesh locally along these lines. So maybe we want to do that. We can do that if I then uninput this thing and instead create a member from this, a member 1D. And if I include this in the create elements from member, we can see that we can do exactly the same thing as shown before, only that this time now we have the, I'm gonna give myself a little bit more space again, we have the option to input a mesh size for the 1D. So I can now create a smaller mesh size here. So now you can see that along these inclusion lines we have a denser mesh. Perhaps we just want to take one side, make it a little bit more clear. So let's just include this one. You can see the rest of the mesh is perfectly normal sized, and along this line we have a denser mesh. You can also see it here in plan. And yeah, again, this is fully parametric. You can change the mesh size, you can change the location of this. You can see how the endpoints are included, and yeah, we can change everything.